So, we've seen AI do some pretty wild things, right? It can paint incredible pictures, it can write entire articles, it can even compose music. But what about the really abstract stuff? What about pure mathematics?
I mean, can an AI actually discover something new? Not just crunch numbers faster, but have one of those aha moments? A genuine creative insight that cracks a problem mathematicians have been stuck on for years? It's a question that really gets to the heart of what we think machines can and can't do.
Well, it turns out the answer is starting to look a lot like yes, and it's thanks to a new system called AlphaEvolve. This thing is exploring the incredibly complex world of mathematics in a way that doesn't just help humans, but sometimes it even goes beyond our own intuition.
So, what's the trick? How does it actually work? Well, the secret sauce here isn't just about being a faster calculator. Instead of just trying to brute force an answer, AlphaEvolve is all about evolving the strategy for finding the answer. It's a completely different way of thinking.
Think about it like this. Most old-school methods are like a lost hiker just trying thousands of random paths, hoping one of them leads to the top of the mountain. It's all brute force. AlphaEvolve, though, is way smarter. It's like creating thousands of expert map makers, and each one has a totally unique strategy for finding that peak. See the difference? It's not evolving the path itself, it's evolving the best way to find the path.
The folks who built it call this the search mode. And here's the really clever part. AlphaEvolve doesn't just spit out final answers. It writes tiny little computer programs. They call them heuristics. And then it tells each program, okay, you've got a time limit. Go find the best thing you can. This is brilliant because it uses the AI's creativity to design smart search strategies, which can then go off and explore millions of options all on their own.
And the way it improves is through a classic evolutionary loop. It's pretty simple, actually. First, a large language model just generates a bunch of these little search programs, kind of like mutations in a gene pool. Then each program gets a test run. It gets a score based on how good a solution it found. The best ones, the high scores, get selected to be the parents for the next generation. And you just repeat that cycle over and over. Generate, evaluate, select, repeat. With every loop, the population of search strategies just gets better and better.
Okay, so that's the theory. Sounds cool, right? But does it actually deliver? Let's take a look at what happens when you put this thing to work on some famously tough problems. This is where it gets really fun.
First up, we've got a real classic, the Kakeya needle problem. So the puzzle is, what's the smallest possible area you need to be able to spin a 1-inch needle around a full 360 degrees? It's a tricky geometric problem, and finding the most efficient shapes is super hard.
And this right here shows you everything you need to know. On the left, that's a famous human design. It's elegant, it's symmetrical, it makes sense. But on the right, that's AlphaEvolve's solution. It's weird, right? It looks messy, irregular. But guess what? It's actually more area efficient. It found a better answer by exploring a weird, counterintuitive path a person probably never would have thought to try.
All right, next up, we're diving into something called the autocorrelation inequality. Now, this comes from a field of math that's, well, it's incredibly complex. Even the researchers said that trying to solve this with computers is difficult. It's the kind of problem where normal computer methods just get totally stuck. And just look at the function AlphaEvolve came up with to set a new record. It's so jagged and strange. It's that very irregularity that probably tripped up all the older methods. But because AlphaEvolve was evolving its strategy, it was able to navigate this weird landscape and find a better solution than anyone had ever found before. But honestly, those first two, they were just the opening act. The real showstopper, the most mind-blowing result, came from a problem that people have been kicking around for more than 300 years. We're talking about a debate that started with Isaac Newton himself.
The question is about something called kissing numbers. It's a simple idea, really. In our normal 3D world, you can get 12 basketballs to all touch one central basketball at the same time. But what about in other dimensions? Specifically, what's the absolute maximum number of spheres you can get to kiss a central sphere in 11-dimensional space?
For the longest time, the best-known arrangement could fit 592 spheres. AlphaEvolve went to work and found a stable arrangement for 593, a new record. It pushed the boundary on one of the most famous problems in all of geometry. Now, finding something cool is one thing, but in the world of mathematics, a discovery doesn't count for anything until it's backed up by a completely solid proof. And this is where AlphaEvolve stops being a lone genius and becomes part of a team.
You can't just walk into a maths department and say,
Hey, check out this cool pattern my computer found. You have to prove, with cold hard logic, that your discovery is correct and it's always true. For centuries, that's been a job only for humans. Well, until now.
So what the researchers did was build this incredible AI assembly line. First, you have AlphaEvolve, the explorer, out there finding promising new patterns. Then, it hands off its discovery to another AI, DeepThink. DeepThink analyzes the pattern and writes up a proof. And finally, that proof gets sent to AlphaProof, which translates the whole thing into computer-verifiable code. It's a complete pipeline, from a brand new discovery all the way to a formally verified result.
So wait a minute. If AI can discover, prove, and verify new mathematics, should human mathematicians start looking for a new line of work? No, not at all. In fact, this whole new process actually shows us just how important a human expert really is.
Take a look at this graph from the study. It shows that, yeah, you can throw more computer power at a problem and get an answer faster, but it actually ends up costing way more in total computation. Deciding on that trade-off, do we need the answer fast or do we need it cheap, that's a strategic decision, and that's a human call. The human is absolutely critical here. You're the one who frames the problem in the first place and designs the scoring system that tells the AI what good even looks like. You're the one who gives it hints and expert advice in the prompt, which the study found had a huge impact on how well it worked. And maybe the biggest job of all, you're the one who looks at the AI's weird alien-looking outputs and figures out what they actually mean for the bigger picture of mathematics.
And really, it all comes down to this one line from the researchers themselves. They said, it was the combination of human expertise and the computational capabilities of AlphaEvolve that led to the best results overall. This isn't about AI replacing people, it's about a partnership. The AI is this amazing new tool that can see things we can't, but it needs a human to guide it and make sense of what it finds.
Which leaves us with one last really exciting question. If this kind of approach works for something as abstract as pure math, what else could it do? Think about materials science or drug discovery or any other super complex field. What new worlds could we discover when we pair human intuition with an AI that can literally evolve its own way of finding things? We might be standing at the dawn of a whole new way of doing science.